Oh yes, good morning. How are you today? This is Kamala, tutor, educator, mathematics and physical sciences, grades 8 to 12. Now today we are continuing with our memorandum of 2025. This is paper 2 chemistry. And if you missed out video 1, check out on the link below to access it. Now today we are doing question 2, question 3, and question 4. Yes, as we do it, please understand. If you don't understand, you can call us on 0785 222041. Yeah, let us proceed. Question 2. Question 2. It says here that the letters A to G in the table below represent organic compounds. Okay, organic compound, and then they say that is A, B, C, D, E, F, and G. Question 2.1. Question 2.1, we say write down the letters that represent each of the following. An alcohol. Now, an alcohol is an organic compound which you can see by the name, which ends with the OL, like ethanol, propanol. They end with what? With the OL. All an alcohol, if it gives you the structure, it's going to be ending with the OH. Okay. If it ends with the HO, like in this case, this one is analdehyde, not alcohol. Then, however, so if we don't have the OH anywhere, or if we don't have the OL in the name, like this one here, like pentane one all, then if they give us like now look at for the molecular formula and they see what contains O. This one is HO, so we'll not do it. This one is there is no O here, so we can't talk about E. Let's look at D here. Look at our D. Let's find out whether it is an alcohol or something else. Okay, let's find out now. Now, if you check here, what we have, these are 4 carbon atoms. Okay, so I'm gonna do like this now. Let's find out if that's an alcohol. That's our D there. It's alcohol. Now, because there are carbon atoms here, I'm gonna say this is 1, then 2, 3, and then 4. Now, remember, alcohol must be having OH. So this is OH like this. So this is 1. Okay. 2, 3, 4, 5, 6, 7, 8, 9, 10. I see there are 10 hydrogens here, which means the answer is going to be D. So the answer is D. So D is the alcohol here. Next question here. They say that 2 compounds that are functional isomers of one another. Now in DB grade 12, the functional isomers, we have got 2 types, but before that, how do you define functional isomers? Now, functional isomers, these are organic molecules which have the same molecular formula, but they have different functional groups. And in here, we know we have the esters and the carboxylic acids. Also, we have the ketones and the aldehydes. So in this case, if you look at our given compounds, we don't have any 2 oxygen atoms anywhere. So we're going to talk about the aldehyde and the ketone. If you look at our A and this our C, now with the A, because we have this one here, the carbonyl group, so the ketone. How many carbons are they? 1, 2, 3, 4, 5. So there are 5 carbons in it. Okay. Now if you check here, because of this HO, this is aldehyde. That's for part C. How many carbons are they? 1, 2, 3, 4, 5. So there are also 5 carbons. And so because of the ketone and the aldehyde, so the answer must be what? Must be A and C. So A and C, they are the isomers, which are functional isomers in this case. So for 2.1.2, we have what? We have A and C. So we have A and C. We have A and C. Now they say 2 compounds belong to the same homologous series. Now homologous series is a series of organic compounds which can be shown by what? By the same general formula. Okay, and they differ from each other by a CH2 group. So here, which ones have got the same homologous series? Let's find out here. So here, this is a ketone, this is a and alkyl halide because of the chloro and the carbons, and this is alcohol. We saw it already. This is pentane. Now our E is C3H8. If you look at that E there, you can write it as C3, okay, C3, then H, 2 times 3, okay, 2 times 3, and then plus 2, which conforms to Cn H2n plus 2. And because of this now, we know these are what? These are alkanes, like this pentane. So the pentane together with this E, which is propane, they are all alkanes, and so we say they have the same homologous series. So the answer is E and F in this case. So here we're gonna have what? So the answer is what? It is letter E and letter F. Okay. Now they want IUPAC name compound A. Now compound A, let's check it out here. This is the compound A here. As you can see, it is a ketone. So being a ketone, we are gonna name it ending with ONE. So the ketones end with the ONE. And so how many carbons are there now? So we can say carbon number 1. If we say this is 1, 2, 3, and then 4. Now in this type of naming, on carbon number 3, we have our functional group, which is the carbonyl group. But however, if you look at this other side here, by starting from 1, 2, 3, and 4, now the one in blue, the carbon number 2 is the carbonyl, so containing the functional group. So in the IUPAC naming, we follow the carbons, the lowest number. So here must come from the left going to right. So in other words, this ketone has got how many carbon atoms? 1, 2, 3, 4. So we're going to have butane, and then you have got a branch on carbon number 3, okay, and it's a methyl. And so what are we going to say in this case? So begin with the branches here. So we say 3-methyl butane 2,1. It's going to be 3-methyl butane 2,1. 3-methyl butane 2,1. We're going to say here it is 3-methyl butane 2,1. 3-methyl butane 2,1. 3-methyl butane 2,1. So this is the IUPAC name for compound A. It is 3-methyl, meaning on carbon number 3 there is a methyl, then butane, because of the 4 carbons here, like you see, these are 4 carbons here, and then 2,1 on carbon number 2, we have the carbonyl group. Okay, hope we are together. Let us proceed. Compound B, I name now compound B. Now compound B, let's find it out here. This compound B has got how many carbon atoms here? This is 1, 2, 3, 4, 5, 6, 7. We say that you must locate the continuous carbon chain first. The longest continuous carbon chain must be located first. Okay. So if you check here, it's going to be this one here. Okay. It's going to be this one here. The longest continuous carbon chain. Okay. Longest continuous carbon chain. Now, if I count from the bottom here and I say 1, 2, 3, 4, 5, 6, let me do it in red color here. If I set carbon number 1 here, and then number 2, and then number 3, number 4, carbon number 5, number 6, and 7, and then another student, but now they use carbon now. Let's see now, I'm using a green color here now. They said it's carbon number 1, okay, carbon number 2, and they say carbon number 3, and the carbon number 4, carbon number 5, okay, and then number 6, and then carbon number 7. So there's 7 carbon atoms in total. We're going to use hepty, okay? And then if you look at our branches now, where are the branches? The branches, we have them on carbon number what? For the one in the red, for the red color, where do we have the branches? Let's find. We have them on carbon number 2, okay? That is for the chloro, carbon number 2. That's for the red, and then also carbon number 6, okay? And then this other one, which is the methyl, is carbon number 2, and then carbon number 5, okay? Carbon number 5. So if you look at the sum here, 2 plus 6 gives us 8, okay? And 2 plus 5 gives us 7. We are trying to determine which side should we go. Now if you look at the green color, now the green ones here, if you start from top here, 1, 2, carbon number 2, we have the chloro, okay? Carbon number 2, we have the, and then carbon number 3, carbon number, this is 2, 3, 4, 5, 6, and then carbon number 6, we have another chloro here, so this is still 8, new 8. What about the branches? Now for the methyls in green, this is number 3, okay, this branch, carbon number 3, carbon number 3, and then carbon number 1, this is 1, 2, 3, 4, 5, 6, and then 6, okay. Now you see carbon number 6 has made the other methyl, okay. Now if you add the 2 plus 3, 3 plus 6, you get 9, okay. Now if you check properly here, this one is lower, this one is lower, this one is 7, right? Lower than the 9. So the preference must be the red numbering here. So from left to right, and so we are gonna say we're taking the one which is red, okay? So the green does not count according to the IUPAC naming system. So green, we don't want you here. We want now the red one here. Okay. So now our red numbering system here, as you can see, where we have the branches, carbon number 2 for the chloro, and number 6. So we're gonna say 2,6 dichloro. We say what? 2. We're gonna say 2, comma 6 chloro, 2,6 dichloro. We got it here. 2, okay, comma 6 dichloro. Di meaning there are 2 dichloro, okay. And then from there now we have the methyls, on carbon number 2 again, that's a 2 methyl, and the carbon number 5, then 2,5 dimethyl, 2,5 dimethyl, okay, dimethyl, and because these are only single bonds, it is an alkane, so dimethyl. Now the longest carbon chain is got 7 carbons, so dimethylheptane. So this our answer is 2,6 dichloro, meaning there are 2 chloro at branches here, and the 2,5 dimethylheptane. So this is our IUPAC name for this compound B. And I hope we are together. Let us proceed. Next question here. They want IUPAC name of compound G. Now compound G is this one here. So its IUPAC name must contain the double bond, okay? So meaning you cannot say that your longest continuous carbon chain will come like this one here, like this, because if you say like this now, it will be not in the bond, which means this one is not correct, So for that matter, we have to change it and say it may be like this now, okay? It could be coming from the top here, like this, then include the double bond, okay. Then you go down here like this, okay. We are together. Now, as you can see, if I count from the bottom here, the double bond is on a bigger carbon number, like this carbon number 1, 2, 3, 4. But from the top, 1, 2, it's on now carbon number 2. So I better begin from the top here. This is my carbon number 1, okay. Carbon number 2, carbon number 3, carbon number 4, then number 5, and then number 6 here. So because 6 here, I'm going to use hex now, okay. So where do I have the branches? On carbon number 2, there is a methyl, and the carbon number 3, there is ethyl. We're going to say 3 ethyl. We're going to say 3 what? 3 ethyl, right? 3 ethyl, 3 ethyl, then 2 methyl, right? 2 methyl, 2 methyl, okay. And then because there are 6 carbon atoms, I'm going to say hex2 in. Hex2. This hex is for the 6 carbon atoms. Hex2 in. Hex2 in. Now alkenes, when we name them, we end with ene. Okay. That's our answer for compound G IUPAC name. We are together. Now they say the structural formulae of two straight chain position isomers of compound D. So that is question 2.2.4. They want straight chain positional isomers, okay, of compound D. Now, what are positional isomers? These are organic molecules which have the same molecular formula, but they have a different position of either the side chain or the functional group on the parent chain. Okay, let's find out now. So compound D is an alcohol, like we saw already, and because there are 4 carbons, it's butane O. Now that butane O, if you put on carbon number 1 becomes butane 1 ol. What about number 2, butane 2 ol? So because there are 5 carbons here, I'm gonna use 4 carbons as well here. So I'm gonna say here they want to. I'm gonna say here this is 1, okay, 2, 3, and then 4. So because I want a straight chain, but they said straight chain, okay, I will not shorten the branches. So I'm gonna say here 1, 2, 3, and then 4. So what I'm going to do is to value the OH. So I can put the OH on carbon number 1 here, like this. I can put the carbon number 1 here, okay, and then on the other one, I can put on carbon number 2, the OH, okay, carbon number 2, and then now I put the hydrogen atoms. So what here now, these are the 2 straight chain positional isomers of this alcohol, and that's what they wanted. If they say structural formulae, they mean you should show all the bonds. If they had said condensed, then I would ignore some of the bonds. Okay. If they say molecular formula, that's what they gave us. So in here, don't forget that each carbon must be having four bonds, not more than 4, and not less than 4. Okay. So even here, all right, and then even here there must be 4 bonds. Okay. So hope we are together. So this is the question 2.2.4. All right. They say here now I'm on 2.3. Compound E reacts with oxygen according to the balanced equation below, this one here. And then they say that what should we do now with compound E? They say compound E, this C3H8, okay, reacts with oxygen according to the balanced equation. This is C3H8 plus 5O2 give us 3CO2 plus 4H2O gas. These are all gases here. So this is propane plus oxygen to give us carbon dioxide gas plus steam. Now they say that initially we have 8 cubic centimeters of compound E and 50 of oxygen. They were injected into the container of adjustable volume and allowed to do this reaction here. Write down the name of this type of reaction. Now, because we are burning with the oxygen, okay, we call it combustion. So this is combustion reaction here. It's called combustion reaction. It's called the combustion reaction. Combustion reaction. Okay, then they say calculate the total volume of the gases present in the container at the end of the reaction. So because we want the reaction, meaning that some are going to be used up in the reactants, they're going to have the products here. Now, because some will remain on the reactants here, at the end, you're going to have some remaining either for the propane or oxygen, the volumes for the products. Okay, so here we go. So we have the propane plus, now they said that initially 80 of compound E. So this is 8 cubic centimeters for compound E. Okay. And then they say that and 50 for the oxygen. So this is 5 for the oxygen. Okay, centimeters cubed. And then they say the reactant. Now from 1 mole ratio here, as you can see, the 1 mole of propane reacts with the 5 moles of oxygen. Mean that if you've got 8 here, if you've got 80 cubic centimeters of propane, okay. Now because this is 5 here, what is 8 times 5? You get 40, né? So I only need 40 here, cubic centimeters, okay. And then in this particular case, because oxygen is in excess, it means propane is the limiting reagent here. So propane is going to be used up completely, okay. And so we don't have any remainder propane, okay, because it's going to be used up completely, right, guys? And so because of that, we're going to have 0 remaining for the what? For the propane. Then for the oxygen, the 50 minus 40 gives us 10. So the 10 will be in excess, okay? Now, because propane is the limiting reagent, we must use it to get our products, né? Otherwise, we can't use the one which was the limit, which was the excess. So this is a ratio of 1 to 3. What is 8 times 3? Now 8 times 3, it gives us 20 what? It gives us 24. Okay, so at the end, we have 24 centimeters cubed of carbon dioxide. And then we have steam. This is 4 here. So 8 times 4, it gives us 32. Okay, 32 centimeters cubed. Now the question said they want the total volume. Né? So our total volume here, we are going to add the one which is in excess, which is the 10 here. So the total volume, okay, is going to be given by the 10 from the excess of what? Of the oxygen, okay, of oxygen here. And then that's the 10 from what? 10 from oxygen, because it was in excess, né? So here we have the 10 here for the oxygen. So this is from oxygen. And then for the products, we have 24. So plus 24 for carbon dioxide. And then plus 32. Plus 32 here. Now 10 plus 24, that is 34. And 34 32, that is what? 60. So the total volume N is 66 centimeters cubed. And I hope we are together. All right, let us proceed. Question 3. It says that the two bottles contain compounds A and B. contain compounds A and B, okay, of the molecular formula, that is C4H8O2. These compounds are straight chain organic molecules that belong to two different homologous series. Now note that in this case, they don't have branches, okay? And then they say the boiling points are used to distinguish between the two organic compounds, okay? Now they define the term homologous series. So we define homologous series. How do you define homologous series? Now, homologous series, you must know your definitions. How do you define it? Anybody who knows how to define homologous series? We say it is a series of organic compounds that can be described by the same general formula. Okay, we're saying that it is a series of organic compounds which can be what? Described by the same general formula, whereby each member differ from the other by the CH2 group. Okay, let us proceed. Identify the two homologous series these compounds belong. Now, because they're saying that they have different homologous series, and as you can see, we have got the two oxygen up here. So now this must be functional isomers, okay? Mean that them must be carboxylic acid, that must be what? An ester. Okay, so because the two oxygen atoms, okay, let us be here. So if they say the two, so you're gonna say carboxylic acids and esters. That's what we have here. You're gonna say what? Carboxylic acids. You know that carboxylic acids, they functional isomers with what? Esters. So here we say carboxylic acid, then also the ester. Okay, let us proceed. Now they say here that the following are the vapor pressures of these compounds at a given temperature. So for compound A, 0.071 kilopascal, that is for compound A. 0.071 kilopascals, 0.071 kilopascals, okay. But for compound B, it is 9.7 pascals, okay. And then they say here that write down the structural formula of compound A. Now, these two compounds, they have got the same molecular formula, but because they are giving us different vapor pressures, okay, it means that they have got different boiling points, okay, and because we are having a lower vapor pressure at compound A and a higher at compound B, means that compound A must be having a higher point than compound B. I repeat, because compound A has got a lower vapor pressure than compound B, so from common sense, the compound A must be having a higher boiling point than compound B. Are we together? And so now they say the structure formula of compound A. So our compound A, now out of the carboxylic acid and the esters, carboxylic acids have got a higher boiling point, and so this must be the carboxylic acid here for compound A. Okay, this must be the ester. Okay, but then the question wants us what the structural formula. Now our compound A, because they said they are all straight, they said here they don't have branches. They said they are straight chain organic molecules. Remember that, So now this carboxylic with the four carbon atoms must be butanoic acid, but we want the structural formula here. Now it contains four carbon atoms here. So you're gonna say this is 1, okay, 2, 3, and then 4. Now being carboxylic must have the OA, the two O's on the either the first or the last carbon atom, okay. So this is what we have here. Don't forget each carbon atom must be having what? 4 bonds, not more than 4 and not less than 4. All right, so here is our structural formula here. and then we said that it is carboxylic acid because it has got the lowest vapor pressure, mean that must be having the highest boiling point. Okay. Now then compound B, they're saying possible name of compound B. Now compound B is an ester. Now the ester here, because there are 4 carbon atoms, we can use the 2 carbons for the carboxylic acid and the other 2 from the alcohol. So we can say it ethyl ethanoate. So the possible answers be ethyl ethanoate, could be ethyl ethanoate. Okay, they're saying possible answers next. So we can put down with 2 carbons there. Could be ethyl ethanoate. Okay, ethyl ethanoate. Or if it only has if it has got actually 3 carbon atoms for the alcohol, could be propyl. What's correct here? You can say propyl methanoate, or could be methyl propanoate. Now for the methyl propanoate, mean that now the methanol was what? The alcohol, ne? Okay, propanoate. Okay, so choose any of these three, choose one of them, they're all correct. Because they said a possible, so we choose any of the three. Okay, let us proceed here. Then they say here that write down the strongest type of Laval's forces between the molecules in compound A. Now compound A we said is carboxylic acid, and being carboxylic acid, those are called hydrogen bonds. So we have here hydrogen bonds. So yeah, we have the hydrogen bonds, okay. And then compound B, being an ester, we call them dipole forces. Okay, we call them what? Dipole forces. Dipole forces. Okay, let us proceed. Now, which compound A or B has a high boiling point? Give a reason for the answer by finding the strength of the interposes. No, we said that compound A has got what? The higher boiling point. Okay, so we said compound A is what? Is the higher boiling point. Then the second reason for your answer. Now, compound A has got hydrogen bonds between its molecules, and so unlike a compound which has got what? The dipole force between the molecules, and so because of that, more energy is going to be required to overcome the forces in compound A than compound B, and hence a higher boiling point. I repeat, they say which compound A or B has a higher boiling point. Then they say give a reason for your answer. Refer to the strength of the molecular force. So we're saying that is compound A. Compound A has got a higher boiling point than compound B. Why? Because compound A has got hydrogen bonds between its molecules, and so what about compound B? Compound B has got dipole forces between its molecules, and so more energy is going to be required to overcome the intermolecular forces in compound A than compound B, and so a higher boiling point in compound A than B. Hope we are together. Then they say here 3.6 that the boiling point of compound A is measured again on another day when the atmospheric pressure is much lower. How would the boiling point of this compound now be affected? Choose from increase, decrease, or remain the same. Okay. Now, guys, what is boiling point? Now, boiling point is the temperature at which the vapor pressure of the liquid, like in this case compound A, is equal to that of the external atmospheric pressure. So now they're saying that it was measured again at on another occasion whereby it is having what? Is lower. It has got a lower atmospheric pressure. Ne? And so because of that now, mean that we are also going to have what? A lower boiling point. So you're going to say it decreases. I repeat. The question said that the boiling point of compound A is measured again on another day when the atmospheric pressure is much lower. Then they say, how will the boiling point of this compound now be affected? Choose from increase, decrease, or remain the same. And we're saying the boiling point is defined as the temperature at which the vapor pressure, okay, of a liquid, in this case of compound A, is equal to the external atmospheric pressure. So it decreases since it was measured on a lower atmospheric pressure. That was question 3. And I hope you guys were together. Now, our last question for today, question 4. They say here that I studied the three organic reactions 1, 2, and 3 below. Compounds T and W are organic compounds, R and S are inorganic substances. Yeah, then consider only the major products. Ne? So here we have got 1, 3. Now, in such questions, before you do 4.1.1, I think it's better for us to read through all the question here. Let's check it out here. They said that study the three organic reactions 1, 2, and 3 below. The compounds T and W, the organic compounds. Then our R and the S are inorganic substances. Consider only the major products. Ne? So W, then W plus sodium hydroxide to give us this one here. This alcohol plus R. Then alcohol with this S to give us T plus water. Now this write down the IUPAC name of compound W, and then name all formula of compound of R. Then two names of the type of reaction in reaction 1. Name all the formula of S, actual formula of compound T. Okay. Now they say here, IUPAC name of compound W. Now this compound W, we see it is a product after adding HBr to T. Okay. But then the same W here, when you react it with the sodium hydroxide, they're getting what? They're getting this alcohol. How many carbons are here? 1, 2, 3, 4, and then plus R. Now they say the R is inorganic. Ne? So because R is inorganic, it means that our compound W must contain 4 carbons as we see them in this reaction 2. And so, because we're getting HBr with it to give us W, and then we use the same W to give us an alcohol, meaning this reaction 2 must be substitution. Ne? And because of the bromo here, so this compound W must contain what? A bromo, alright? And so compound T must have been an alkene to give us a bromo which contains to give us an alkane containing a bromo. And so for that matter, our W must be an alkyl halide with a bromo. And because reaction 3 substitution, that bromo must be on carbon number 2. This here. Okay, so I'm gonna say it is 2-bromobutane. It is 2-bromobutane. It is 2-bromobutane. It is 2-bromobutane. 2-bromobutane. Why do we say butane? Because you have got 4 carbon atoms in reaction number 2. Okay, now they say formula of R. Now this one being 2-bromobutane for W, okay, plus sodium hydroxide, and we are substituting sodium will go with the bromone. So it give us sodium bromide here. Sodium bromide, okay. And then they say the two names for reaction 1, okay. Now reaction 1 here, as you can see, because this one is the alkane, this must have been an alkene for T. So the alkenes plus HBr, it's gonna call the addition reaction. So We can either say addition, and the first name we can say addition reaction here, addition reaction, okay. And because we are adding HBr, you can also say it is what? Hydrohalogenation. Hydrohalogenation, okay. We say hydrohalogenation. Hydrohalogenation, okay. Hydrohalogenation, okay. And then that's what they want here. Now this the name or formula of S. Now this S here, now the alcohol to give us T, but our T we see it appears here. Ne? Our T appears here. So the T by now we know it is an alkene. So now this alcohol to give alkene, we are removing the water. And so S must be a dehydrating agent. And from our theory, it should be either sulfuric acid or phosphoric acid. So here, you're going to say they use the what? The concentrated sulfuric acid, that is SO4, H2SO4, okay? Now they want compound T. Now compound T is an alkene, okay? And so, meaning what now? So compound T should be an alkene with 4 carbon atoms. Let's put them here. This is 1, 2, 3, and then 4. And as you can see here, this alkene, where do we have the double bond? Is it in the middle here, or is it here on carbon number 1? Okay. Now, where we have our OH, our OH is on carbon number 2. Okay, on carbon number 2. So the bromo must have been on carbon number 2 here, and so this one can be, this should be the answer here, because we wanted we're only dealing with the major products, so meaning you can put it like this now here. Don't forget each carbon must be 4 bonds, not more than 4 and not less than 4. So here this must be the answer now for compound T. They wanted the structural formula where we show all the bonds, okay, where we show all the bonds, and then density formula, we don't show all the bonds. Okay, that's what we have here. Then they say here that now they say here compound W can be converted to compound T in one step. So meaning from W to T, this W is a alkane, to bromobutane, to compound what? To compound T to give us the alkene here. They say besides heat, a state besides heat, one condition for this conversion. Now, guys, we know that when you want to get an alkene from the alkane, you must heat. But they're saying besides the heat, what else do we need? Now, what else we need here is the concentrated stronger base, But now here, to be specific, we're gonna say we're gonna need what? We're going to need concentrated sodium hydroxide. So we're talking about a stronger base, Talk about a stronger base, so it's concentrated sodium hydroxide, concentrated sodium hydroxide. Okay. Then next question here, that is question 4.2. They say here that compound with the formula C2H22 undergoes a cracking reaction according to the equation here. That is the C10H22 to give us 2x gas plus C4H10 here. Now they said the mixture of the two products is bubbled in bromine water in a darkened room. Define the term cracking. Define the term cracking. So what is cracking? Do you know how to define cracking? How do you define cracking? You must know your definitions. Now cracking is defined as the chemical process which longer chain hydrocarbon molecules are broken down to shorter, full molecules. I repeat, cracking is defined as the process in which the longer chain hydrocarbon molecules are broken down to shorter, more useful molecules. I hope you heard me. Then they say here state change besides a change in temperature that will be observed when the bubbled in bromine. Now in bromine, apart from the change, the bromine is gonna color. So we're gonna say here bromine will be decolorized. So we say what? Bromine, okay. Yes, will be what? Will be decolorized, we lose its color. Will be colorized, decolorized. Okay. Its color, decolorized. Or it's gonna lose its color. They here. Write down the search formula of X here. Now before I need to know the molecular formula name for this X here. Now not the cracking. We have two reactions, né? We can form alkene with an alkane or form alkene with the hydrogen. So now because this one is alkane here, this must be alkene here. So we can write that alkene contains the carbons, contains carbon atoms, and then B hydrogen atoms, okay? So now to balance it here, because there are 10 atoms, it means you're going 10 carbon atoms equals to, there is a 2 here, 2 times A, 2A, are we together? And then plus, how many here? 4, then plus 4, okay? Now the 2 minus 4, that is 6, by 2, we get a 3. So our A is what? 3 minus 3 here for that alkene. What about hydrogens now? This is 22, we're going to 22 to, now there is a B here, and 2 times B, that is 2B, okay? Then plus here, give us 10, so plus 10 here. 22 minus 10, 12 divided by 2, our B equals to 6, okay? H6 here. And so, because we want the structural formula, it's going to be propene, that's carbon number 1, then 2, and 3. So here, put our double bond here. Then it must be having 4 bonds for each carbon atom. Okay, so here we're having it like this now. So this is hydrogen and the hydrogen here, and the hydrogen here as well, and the hydrogen here, and then the hydrogen here, another hydrogen here. So this is our structural formula for compound X. Lastly, here they said that which compound X or H10 reacts faster with the bromine? Explain your answer. So the answer is going to be X here. Why? Because compound X contains a double bond. Compound X contains the double bond, and at the double bond there is what? Bromine water. So we say it is compound X because it contains the double bond, and then the double bond react with what? With the bromine water, and make it lose its color. So hope guys we are together. We're stopping here for this video too. Catch you in our next video. If you missed out video 1, check the link below. Don't forget to subscribe and like and share the video so that the algorithm make the videos to circulate. Thank you. Bye bye. See you next time.